Carol Baskin. Killed her husband, whacked him. Can't convince me that it didn't happen. Fed them to tigers, they snacking. What's happening?
In our final video this semester,
Yay!
our main focus will be transhumanism. Transhumanism, generally speaking, is the view that we should be open to the potential for improving both the human condition and the organism itself through technology.
Transhumanists, by and large, see human nature as it is as a work in progress, which we can reform and reconstitute to better achieve our desires and aims. Or, in other words, you might think of transhumanists as advocating for technology to be used in the next phase of human evolution.
Nick Bostrom, professor of philosophy at Oxford University, notes some examples of the ideas discussed in the transhumanist community. Radical extension of human health span, eradication of disease, elimination of unnecessary suffering, and augmentation of human intellectual, physical, and emotional capacities, all through technological means. In particular, Bostrom mentions 5 areas for enhancement. 1. Lifespan. 2. Intellectual capacity. 3. Bodily functionality. 4. Sensory modalities, special faculties and sensibilities. And 5. Mood, energy, and self-control. What would these things look like? Well, for example, we might use nanotechnological advancements to incorporate nanobots into our bodies to help support our immune systems, thereby increasing our health and longevity. Or we might create a brain-computer interface that allows us to access Google straight from our own consciousness, thereby gaining direct access to information. Or we might amplify and expand our 5 senses so that we can smell like bloodhounds and see like the mantis shrimp, or acquire new senses like the echolocation of bats or the electroreception of sharks, or cyborg bodies that give us physical superpowers and new aesthetic possibilities, or...
Okay, we get it. It's exciting. The basic idea from transhumanists is this. We, as human animals, are limited beings. We have limited intellectual capacities, limited lifespans, we're prone to weakness of will, etc. But with the help of technology, we can surpass these limits. It might even be possible for us to reach higher planes of understanding of the universe which are currently outside of our reach. Given that these seem like good things, then we should be open to the possibility of actually fundamentally altering ourselves with technology in order to make these possibilities actual.
If these goals seem fairly general, that's because they are. In discussion of the particular sorts of goals or objectives transhumanists have, Bostrom notes the following. We must avoid, at all cost, methods that carry an existential risk of wiping out intelligent life on Earth, or greatly and permanently reducing its potential to evolve. We obviously need the technology to make these transhumanist ideals a reality, which may require economic and productivity advancements as well. Lastly, we need there to be wide access to the methods and means of transhumanist advancement. It's not enough that some people are able to augment themselves in this way. The goal is for everyone to have this opportunity.
Furthermore, Bostrom suggests that the large-scale transhumanist values lead us to further values. In particular, he thinks that because transhumanists value the things just mentioned, they also value individual freedom and individual choice regarding technological enhancements, international peace and cooperation in order to further global security, the scientific, engineering, and entrepreneurial spirit in order to further technological advancement, the well-being of all sentient life, whether it be AI life, human life, non-human animal life, or otherwise, and the saving of lives.
While this may seem intuitive to many, some worry about the repercussions of transhumanism. One worry in particular is that in changing human nature, as we would while we transition to transhumanism, we would change not only our nature, but would potentially corrupt our values. Journalist William Salatan argues that tinkering with human biology would warp our ideas of perfection and acceptance.
Salatan thinks that what we consider human perfection is inextricably tied to our biology. We admire athletes and thinkers for the extent to which they've developed and pushed the boundaries of their bodies and minds. Both groups must operate within the physical limitations of our biology. By altering our biology to grant us superhuman power and athleticism and intellect, what counts as perfection would no longer be defined by our biology, but by our technology. And since we are the creators of our technology, then really our idea of perfection would be defined by us. Salatin argues that the more successfully we engineered IQ and muscle to fat ratio, the more central these measures would become to our idea of perfection. He concludes that we might create a world of perfect SATs, ERAs, and CEOs, but it would never be a perfect world because the point of perfection is that its definition doesn't bend to our will.
Salatin also argues that tinkering with our biology would twist our idea of acceptance. He thinks that there is something important about accepting and celebrating what we've been given. To some degree, being a good parent, athlete, or performer is about accepting and cherishing the raw material you've been given to work with. Strengthen your body, but respect it. Challenge your child, but love her. Celebrate nature. Don't try to control everything.
But what's wrong with controlling our biology so that we have harder, better, faster, stronger raw material to work with? Salatin fears that engineering our biology will harm our empathy and our sense of giftedness. We might lose empathy because we stop seeing ourselves as sharing the common fate of the genetic lottery, as any perceived defect could be repaired. And instead of cherishing our talents as gifts we've been blessed with, we might view them as achievements that we earned via smart bioengineering.
Another thing one might worry about when considering transhumanism is the ability for transhumanizing technology to be co-opted and used for purposes for which it wasn't intended. Marcello Janka argues that these sorts of technologies can be co-opted for potentially destructive ends, such as military purposes. For example, many governments have developed or are developing products that use brain-computer interface technologies to assist soldiers on the battlefield, or products that use neurotechnology to help train soldiers.
While this might not seem worrying to everyone on its face, Janka outlines a number of ways this could be dangerous, particularly in its possibility of eroding or destroying democratic institutions and democracy itself. It's possible, given the way that these sorts of technologies can be co-opted and used for undemocratic ends, such as using the data collected from brain-computer interfaces to stifle the actions of particular political parties or individuals voicing political concerns. As such, Janka thinks that one of the major ethical concerns related to transhumanism and the technology required to achieve it is the way in which we approach the connection between the technologies and the democratic systems.
Janka outlines three relevant views on the subject: laissez-faire approaches, strict regulatory approaches, and what he calls the democratizing approach. Laissez-faire approaches emphasize the individual freedom of technology producers and end users, as well as the alleged capacity of financial markets to filter out potentially detrimental applications. Strict regulatory approaches emphasize the need for state-led regulatory interventions, often based on essentialist views on human cognition, according to which the natural cognitive boundaries should not be trespassed through technology.
The democratization approach, which Janka argues is the approach we should take, contains elements of both laissez-faire approaches and strict regulatory approaches. On the one hand, the democratization approach shares the following with laissez-faire approaches: the observation that overregulation can A. obliterate the benefits of cognitive technology for society at large, and, if managed by non-democratic or flawed democratic governments, B. produce an undesirable concentration of power and control. In fact, if adequately implemented, cognitive technologies open the prospects of unparalleled improvement in the quality of life of human societies across a wide range of domains: medical, economic, infrastructural, communicational, etc. On the other hand, it shares the following with strict regulatory approaches: the observation that 1. Cognitive technology requires urgent ethical assessment and policy interventions to minimize the risks associated with its dual use potential, and 2. that markets alone may not be conceptually and practically equipped to provide such assessment and intervention.
Specifically, the democratization approach rests on 6 principles, the first of which is avoidance of centralized control. In short, according to this principle, it's morally preferable to avoid central control of cognitive technologies in order to limit the risk of the potential for unregulated accumulation of capital, power, and control of these technologies by large corporations or governments. The second principle is openness. This principle promotes open access to at least parts of the relevant technologies and their blueprints. The idea here is that we should provide access to the capabilities that are recorded through or infused in the technologies themselves. Generally, this would allow everyone developing or modifying these technologies to use the same building blocks when they do so, as well as allow potential consumers of the technology to view, and in some cases, sample the technology themselves.
The third principle is transparency, which calls for a general public understanding of the internal processes of cognitive technologies. In particular, Yanka maintains that there are 3 domains where transparency is needed. 1. When and for what purposes AI is being applied in cognitive solutions. 2. The main sources of data and expertise used to develop cognitive solutions, as well as the methods used to train the solutions. And 3. Data protection and ownership. Having transparency in these 3 domains has a positive educational impact since it empowers everyone with the information that they need to learn about and use cognitive technologies. The fourth principle, inclusiveness, is about not marginalizing or leaving behind any groups or minorities as cognitive technology spreads across society. Designing and employing tech according to this principle means localizing technologies so that they support local languages, currencies, etc., and making sure that things like facial recognition technology perform similarly for everyone. Inclusiveness is closely related to transparency too. As Yanka notes, building algorithms which explain their reasoning and decision making is the best way to guarantee that hidden biases will be understood and promptly eliminated. In addition, transparent data sources increase awareness of, and therefore the creation of, bigger and more inclusive and diverse data sets for training algorithms.
The fifth principle outlined is user-centeredness. This principle holds that the relevant technologies should be designed, developed, and implemented according to users' needs and personal choices. This is important, according to Yanka, because not only do user-centered technologies generally just function better than non-user-centered technologies, but they would also guarantee that these technologies were designed for users' benefits, as opposed to being designed to make users passive buyers of novel products. The final principle Yanka outlines is the principle of convergence. This principle is a bit more complicated than the others because it has 2 senses, the narrow sense and the wide sense. In the narrow sense, this principle amounts to the insistence on the interoperability, intercommunication, and easy integration between all of its components. This is sort of a practical idea. In order to reach the ultimate goals of cognitive technology and transhumanism, it seems like the components of the individual technologies, at the very least, must be able to talk to one another. In the broad sense, convergence requires that we be able to converge different types of technology with one another. For example, the brain interface technologies that are designed should be able to talk to the AI systems that we produce, and both should be able to talk to the neurotechnologies that we produce. While the narrow sense of convergence is a more practical matter, the wide sense, according to Yanka, might lead to more empowered users of these technologies, as well as provide better control over these technologies and prevent malevolent applications of them.
Again, these principles are supposed to combine to give us an approach that is sort of a middle way between the laissez-faire approach and the strict regulation approach, in order to avoid the problems with both of those views. It makes sense then for us to ask, will this work? Does this view actually avoid those problems? Will this view prevent the erosion of democracy that we potentially face regarding transhumanism and cognitive technologies? We'll leave that for you all to ponder and to debate in the comments.